Now we're going to talk about vertical stretching and shrinking. Some textbooks refer to shrinking as compression. I'm trying to think if there's any other words they use. Okay, so here's what's going to happen. Let's say we have f of x is, let's just say it's the absolute value of x. Okay, so we know what that looks like. There's the common absolute value function. Okay, but now let's say g of x is equal to 3 times the absolute value of x. So what's going to happen is each output is getting multiplied by 3. So instead of going up 1, now we're going to go up 1 times 3. 1, 2, 3. Oh, did I go up 4? I think I did. 1, 2, 3. Okay, so let me do a table of values so you can see what's going on here. And then we'll put f of x in the middle. So that's, f of x is the common one, right? So we're choosing values like -2, -1, 0, 1, 2. We're plugging those in. We're taking the absolute value of each one of them. Oh, I just did a quadratic. Oops. Let's do an absolute value. Rewrite that down. Okay. Now we're multiplying by 3 each time. So each output, so I'm saying, okay, if I put in a -2, g of -2, I would have 3 times the absolute value of -2, which would be 3 times 2, which would be 6. And if I put in -1, I'm going to get 3 times the absolute value of -1, which is going to be 3. If I put in 0, the absolute value of 0 is 0, I'm still going to get 0. And then if I put in 1, I'm going to get 3 times 1, and then 3 times 6, 3 times the absolute value of 2, which is going to be 6. Okay, so that's what the table of values would look like. Now, when we graph this point, -2, 6, where is that? Well, -2, 1, 2, 3, 4, 5, 6, way up here, okay? So you can think about, well, if my output was 3 here, then I have to multiply it by 3. That's going to be up to 9 now. Okay? 0, we already did the -1, 3, right? So -1, 3, that's already there. 0, 0 is going to be right there. So anything that was on 0 is going to stay on 0, because 0 times whatever is still going to be 0. And then we're going to have 1, 3, 2, 6, and then if you wanted to do another point that fits, it's 3, 9. So now we get this shape for the graph. So it's like you drew the absolute value function on Silly Putty and then you stretched it. This is called a vertical stretch. Okay? So a shrink, that occurs. So a stretch occurs when you have like g of x equals some constant times f of x. Okay? That's how it's represented. A shrink, oops, sorry. If c is greater than 1, then it's going to be a stretch like we've shown here. Now, if c is between 0 and 1, then it's going to be a shrink. Okay? So g of x would equal c times f of x, but this time c is greater than, or between 0 and 1. So an example would be, let's take our absolute value one again. So here's f of x being the absolute value of x, but now g of x is something like 1/2 the absolute value of x. So now on your original absolute value, we'll just do a few. But now they're each getting cut in half. So 0, 0 still stays put, but then this is going to go to a half. Half of 2 is 1. Half of 3 is like 1 1/2. Half of 4, if I were to go further. So you get something like that. And then you'd get the same output over here. Oh, oops. So it's like someone took your absolute value curve, your original one, and sat on it. They like squished it. Okay, they call it a shrink. Maybe they should call it a squish. Okay, but that's what's happening. Okay?